Okay, with our secant and tangent lines, we've introduced the basic concept of a limit. So now I'd like to formalize what a limit is and go from there into application of it. So let's start with this intuitive definition of a limit, which is perfectly good for what we're going to be doing in this class. Right out of our textbook, you can go ahead and write this down if you'd like to. I'm just going to read it. Suppose f of x is defined where x is near the number a. Keyword, near. This means that f is defined on some open interval that contains a, except possibly at a itself. Again, an important concept that what we're looking at doesn't actually have to contain a. Then we write the limit of f of x equals L as x approaches a. So I'm actually reading it, what this says here. Again, the limit of f of x, well, another way, the limit of f of x as x approaches a equals L. This is just a clarifying statement, which means it can happen in the middle or at the end, any way you'd like to say it in English, as long as you understand mathematically what's happening. So, if we can make the values of f of x close to L, let's see, arbitrary close to L, as close as L as we like by restricting x to be sufficiently close to a on either side of a, but not equal to a. Okay, so hopefully right now you're thinking back to our secant line example. Because when we had the formula for the slope of the secant line, we wanted the h value to approach 0. And of course we couldn't put in 0, but we could have my second point either to the left or to the right. That would be on either side of 0. So as long as my 2 points were not at the same location, which would have given us a distance of 0, we could estimate the limit. Now, let's look at some graphs and apply this concept. So, let's use this, and we're going to, looking at the graph, find the limit of f of x as x approaches -1. So, this is pretty straightforward. I can go to the graph and look at it and say, aha, the function is going to have an output of 4 there. Seems easy enough. And you might be thinking to yourself, isn't that just the same as f of -1? Let's talk a little bit more in detail about that. Let's take a look at the limit of f of x as x approaches 4. Now we're going here, and let's zoom in on that location. This point does not exist on the function, but the limit does. As x gets closer to 4, if I'm on the function, as x gets closer to 4 from either side, so from either side, as x is getting closer and closer to 4, my function is getting closer and closer to 2. So the y value is getting closer and closer to 2 as x gets closer to 4 from either side. So then I can say my limit is 2. That is, my function is approaching 2 as x approaches 4 from either side. So those are key terms, from either side. Now, sorry with that. Now, let's take a look at another question. What if I was to ask you, what is the limit of f of x as x approaches 2. So I'm going to zoom into my graph. Oops. If I'm on the function and I'm getting closer and closer to 2 on one side, it looks like the function is going to -1. However, if I'm on the other side and I'm approaching on the function, then the y value appears to be 5. So in this situation, I would actually say that the limit does not exist. Does not exist because the function is not going to one location. And again, like our last example here, it doesn't have to reach it, but it has to be going to it. So my function was going to 2, whether I was looking at from the left or the right, but at x equals 2, my function is not going to one location. It's actually going to 2 separate locations. So the limit does not exist. Now, let's take a look at a new definition. It is possible to have a one-sided limit, but we have to be careful in the notation that we're using to say that we're only approaching from one side. So if you take a quick read on this, we write the limit of f of x as x approaches a, and see that negative sign? That means from the left. So I can have from the left, I can also have approach a from the right. So again, x approaching a from the left or the right. And negative side is your left side of the graph. Your positive side for x is the right side of the graph. So let's look at, back one picture, and I'm going to erase this. And start over here real quick like. So let's talk about what we were just looking at a second ago as x approaches 2. So I'm going to write this as both a left-hand limit and a right-hand limit. So, sorry about that. So, I can say, the limit as x approaches 2 from the left side. That's what that negative means. It's not an exponent. Notice there's no number after the negative. It's just a negative symbol, and it means the left side. It's hieroglyphics of f of x. Equals, well, again, let me just erase this real quick. On the left side, that's this side, left of 2 is the negative side. We're approaching a y value. And we're approaching, on this graph, the y value, -1. If I look at the limit as x approaches 2 from the right-hand side, again, of f of x, I'm on the function f of x, I'm on the right side, and this is approaching a different y value. The y value it's approaching is 5. Now, what I had said is that the limit as x approaches 2 of f of x does not exist. Let's review that for just one second. Why doesn't it exist? Because I am not getting closer and closer to one value. On the left, I'm approaching the value -1. On the right, I'm approaching the value 5, and those are different values. So the limit doesn't exist, but the limit from the left does, because as I approach from the left, I'm going to a specific value. The limit from the right exists because as I approach from the right, I'm going to one specific value. They're just not the same value, which leads us to our last little statement. Let's read this. Starting off with this first part. The limit of f of x as x approaches a equals L if and only if the limit from the right side equals L, and the limit from the left side equals L, and the limit from the right side equals L as x approaches a. If those two sides are approaching the same value, then that is our limit from the very first part. So again, notice the limit as x approaches 1 of f of x is, in this case, it does not exist. It does not exist because the limit from the left is 4 and the limit from the right is -2, and they have to be the same for the limit to exist. Now, what's interesting here, let me hit my eraser. Let's take a look at this. The limit of f of x as x approaches 6 from the left. So I'm on my function on the left and I'm approaching 6, then the y value is approaching 5. The limit as x approaches 6 from the right of f of x is, well, let's get on the right and we approach. And what are we approaching? Same value. We're approaching 5. This is important. It's very important because the point f of 6 is 2. However, according to our definition that we just had right here, if the limit from the left and the limit from the right are the same, then by definition it is the limit of the function. So, let's go back. So, the limit as x approaches 6 is not 2. It's not f of 6. Yes, f of 6 is 2, but my function is not approaching 2 from the left. It's not approaching 2 from the right. From both the left and the right, the function is approaching 5. This is an important concept. We're not talking about where is the function when x is 6. We're talking about, f of x here. Little mistake in my notation. So, f of x is approaching 5 as x gets closer to 6 on the left. As x gets closer to 6 on the right, it's still approaching 5. So I can confidently say the function is getting closer and closer to 5 and no other value as x gets closer and closer to 6. Hopefully that sticks with you. Again, we're talking about the concept of approaching, not necessarily reaching. Big difference.